Hi, this is Alex from devstories.eu, DeepEval Framework, episode 18 of 18. You spend hours tuning a prompt locally, achieve a great evaluation score, and ship the code. 2 weeks later, another engineer updates the underlying model, and suddenly the application fails on edge cases no one tracked. Running evaluations locally is only half the battle. This episode covers how to scale your testing and track regressions over time using confident AI. First, a necessary distinction. DeepEval is the open-source framework you run in your terminal or Python environment to execute tests. Confident AI is the hosted cloud platform built on top of it. You use DeepEval to define your metrics and run the actual evaluations. You use Confident AI to centralize, track, and analyze those evaluation reports across an entire engineering organization. It takes isolated local scripts and turns them into a collaborative system of record. Moving from local execution to cloud logging requires one simple step. In your terminal, you execute the command DeepEval login. The CLI will prompt you to provide an API key generated from your Confident AI workspace. Once you authenticate, your daily workflow stays exactly the same. You run your test files using the standard test command. The framework automatically detects the active session and streams the results directly to the cloud dashboard while still printing them locally. Centralizing reports unlocks the ability to track regressions methodically. A regression happens when a change in your code or configuration inadvertently degrades the system's performance. To diagnose why a regression occurred, you need to track exactly what changed between test runs. This is done by logging hyperparameters. In the context of language model evaluations, a hyperparameter is any variable that alters your pipeline's behavior. This includes the model architecture, the temperature setting, the chunk size used for retrieval, or even the specific prompt template version. When you configure DeepEval to log these hyperparameters, they are attached to every test run sent to Confident AI. Consider a team attempting to upgrade their application. They want to know if switching from GPT-4o to Claude 3.5 Sonnet actually improves their overall pipeline score. They configure the model name as a tracked hyperparameter. When the engineer runs the evaluation suite using the new model, Confident AI logs the new model name alongside the resulting scores for metrics like contextual precision or factual consistency. Here is the key insight. Because all historical test runs are saved in the cloud, the team can view a timeline comparing the exact hyperparameter changes against the aggregate evaluation scores. If switching to the new model increases answer relevancy but drastically drops factual consistency, the dashboard highlights this regression instantly. Everyone on the team sees the same data. You never have to parse through old console outputs or rely on memory to decide if a configuration change was a success. Continuous evaluation requires a historical baseline. Without a centralized system tying your configurations directly to your evaluation scores, you are simply running isolated experiments, not engineering a reliable system. This concludes our series on the DeepEval framework. I highly encourage you to explore the official documentation and try building these evaluations hands-on. If you have technical topics you would like to see covered in a future series, visit devstories.eu to leave a suggestion. Thanks for listening. Happy coding, everyone.